Hi, this is the flipped classroom number 12. Welcome. Are you in your school uniform? The school uniform for the flipped classroom is some comfy, warm, large shirt and some nice leisure pants or jeans. No shoes, but comfy socks. Have your comfy comp book out and ready, and we're all set. Title this page, I think you're on 129. It's a new page in your comp book, and title it the half angle IDs. And we're going to start to develop it. If you would write down this development, I would like to, haven't been checking, so I want to check tomorrow that you've written down the development, so you'll have credit for seeing this video. I would like you to recall that this came from today, or last video. We actually developed it on the board today as well, and it was one that had three different forms. Well, the cosine of double angle, I'm going to start with this form. What we're going to do with that, once you write that down, I would like you to rearrange it, and I want you to get sine squared by itself. So you can look away, and I'll do it quietly as you do it in your comp books. So I'm going to move it over to the other side where it's positive, and I want to get that by itself. Alright, let's see if you were able to come up with a similar statement as I was. To get this by itself, I moved it over to the left by addition, where it became positive, and I moved the cosine of 2a over to the right, where it became negative. And then all I had left was a 2, and I divided both sides by 2, and I got the square. Oh yeah, now I'm going to go from sine squared to just sine. So join me and take the square root of both sides. That creates a plus or minus on the right, and I'm just going to erase my square and square root, and it becomes sine of a equals plus or minus big square root 1 minus cosine of 2a over 2. That's where I need to be today, because this will get us to the sine of half an angle like this. This formula, and all formulas like it, can be used for anything you want to put in it. So I could put sine of 30 degrees equals plus or minus square root 1 minus cosine of 2 times 30 degrees divided by 2. Now, I can use radian measure. Sine of pi over 6 equals plus or minus square root 1 minus cosine of 2 times pi over 6 over 2. I can put anything in for a. I could put in sine of a star equals plus or minus square root 1 minus cosine 2 star divided by 2, or anything, and we've learned in the past that formulas are like that. Well, guess what I'm going to put in for a? I'm going to put in a over 2, and that works as long as I put in a over 2 here. So let me just do it by erasing, since I'm running out of space. You can rewrite this as your next line. So I'm going to put a over 2 there, and that causes me to put a over 2 here. So now I'm going to simplify that. That gives me plus or minus 1 minus, this simplifies to just a, and over 2. So this is our next trig ID. It goes on your trig ID page as well. And I forget the number we're up to, but we'll talk about that tomorrow. I'm sure you are aware. And I'm going to give you the cosine of half an angle instead of developing it, because my voice is very limited tonight with this cough cold thing. So you will see if you start with the other form of cosine of 2a, it can also be developed. So, and the other form looks like this. Cosine of a over 2 equals plus or minus 1 plus cosine a divided by 2. So you can see it's very similar in that the only difference is the SIGN right here. This one is plus and this one is minus. So get that down in your trig ID pages and we'll see how to use these two. Alright? You can pause if you need more time, and I'm going to show you how to use them. Alright. We're going to use these to find the exact answer to sine 105 using half angle IDs. Sine of 105 could be found on your calculator, but it'll just be a decimal that's a close approximation. We're going to find the exact answer. So the sine of 105 can be thought of as the sine of twice that, which is 210 divided by 2. So why would I want to take 105 and double it? To see if it gets me to an angle that I'm familiar with. And you'll notice that 210 is one of those special ones on the unit circle. So the sine of 210 divided by 2 is going to work. Using the formula that I just developed for sine of an angle divided by 2, I recognize it's plus or minus big square root 1 minus the cosine of angle A, and this is my angle A, 210 divided by 2. So when we simplify that, it looks like this, plus or minus 1 minus, and if you look on your unit circle, the cosine of 210 is a negative square root of 3 over 2, and there's a negative in the formula, and the cosine of 210 is also negative. So now the only thing I can do to simplify that is inside of here, this double negative becomes a positive, and I can clean that up a bit. If I give this numerator the like denominator, so we're looking at the denominator of the numerator, so if I want to give this the same denominator as this, it can be called 2 over 2, can it not? So that becomes square root of 2 plus square root of 3 over the common 2, and still under the radical there's a 2. So I'll make it 2 over 1. So all I did was algebraically add in the numerator, and now I have a fraction divided by a fraction, which we've learned that it's the same as flipping it and multiplying it by the reciprocal. The flip reciprocal of 2 over 1 is 1 over 2. So now the final answer is plus or minus square root of 2 plus square root of 3 over, now the denominators multiply to give you 4. This can also be simplified because I know the square root of 4, so I can actually pull it out of the radical and call it a 2. Now, is there anything more I can do? Plus or minus the square root of 2 plus square root of 3 over 2 outside of the radical. There's one more thing, and that is we're not going to accept the answer plus or minus. The formula is not equipped to tell you whether it's plus or minus, but your brain is. Your brain has been trained. Because look where we are. Sine of 105 was the original problem. What quadrant is that? Well, here's 90. Here is 180, so 105 is somewhere in there. probably a little closer to the 90, like that. So that is in quadrant number 2. And we're asked for the sine of an angle in quadrant 2. Is that a positive value or a negative value? All students take calculus tells us that in the second quadrant, sine is positive. So I don't need that negative any longer, and we usually don't write positives because they are understood. So here is the best and final answer. All right, that's the kind of problem you'll be doing tomorrow, and in addition to the sine and cosine of a double angle, we'll have some half angle problems as well. So this is short and sweet because of my throat, so hopefully you understood my voice and that you will come in ready to go with these type of problems tomorrow. So till then, good night.